All right, guys, we're going to talk today about the inverse of a square matrix. What is a square? It's a square. Tell me about a square, guys. What about those four sides? They're all equal, okay? A square matrix has the same dimensions, like a 2 by 2 or a 3 by 3. Same size row, same size column. We are only going to be discussing inverses of 2 by 2s. Okay, so a couple different things that we're going to talk about today. We're going to be fairly quick, and then you guys have a webisode that you can start on. But inverse notation. Remember when we found inverses algebraically, and you would tell me that the inverse was f negative 1 of x, right? You put a little negative 1 up here. Same thing is going to apply for inverse of matrices. If you have a matrix and you're going to tell me, oh, I found the inverse, it's denoted with a capital letter and then a little negative 1 up here. This is called inverse, if I could spell it, inverse notation for matrices, right? A little negative 1 up. Yes, you need to have that in your answer because this says, hey, this is the inverse. Now, you're going to be asked to find inverses, and you're going to be asked to prove that things are inverses of each other. This is called the identity matrix. Identity matrix. All right. When you are asked to prove if two matrices are inverses of each other, when you multiply them together, this is the result. But the thing that's special about multiplication, very special about multiplication. All right, special about multiplication, we talked about this yesterday. If I multiply A times B, is it always the same as B times A? No. It's not always the same with matrices. Why? How do we multiply matrices? What has to be the same? The middle, when you write the dimensions, the middle terms have to be the same, and the outsides will be the answer. So when you are proving that two things are inverses of each other, you have to multiply, I'll say forwards and backwards. Generally, they give you A and B, but you have to multiply A times B, and then you got to flip it around and do B times A. If both times you get the identity matrix, then they are inverses of each other. So let's do one of these. We're going to show, it's telling you to show that B is the inverse of A. So they're already telling you, okay, look, these are inverses. So the first thing I'm going to do is I'm going to multiply A times B. I have to go both ways. I have to say A times B, and then I have to multiply B times A. Can I multiply these two together? Yes, this is a 2 by 2, and this is a 2 by 2. Since these two in the middle are the same, we can multiply together. So if I multiply A times B, all right, I'm going to multiply A times B. I'm going to try and do this without, actually, let me write it out for you. I'm going to do it without highlighting so you guys can kind of get into the habits of seeing it because you're not going to probably have highlighters on your test. Some of you might, but when we multiply, guys, okay, we're going to find out when I multiply these two together, what does it give me? So think about it. If I'm going to find this top left piece, it's first row times first column, correct? So negative 1. Okay, so negative 1 times 1 is what? Negative 1. And then 2 times 1 is what? Plus 2. So what's negative 1 plus 1? Okay, so now we're going to come over here. And I'm going to say first row, second column. So negative 1 times what? Negative 1 times what? Negative 2 gives me 2. And then 2 times negative 1 is negative 2. What's 2 minus 2? 0. All right, now I'm going to come down here. I'm going to find this piece right here. So I have second row, first column. What's negative 1 times 1? Negative 1. And then I have second row, first column. What's 1 times 1? Plus 1. What's negative 1 plus 1? 0. Now I'm going to find bottom right. So second row, second column. What's negative 1 times negative 2? It's going to be 2. And then 1 times negative 1 minus 1. What's 2 minus 1? 0. 1. Why do I keep saying 0? Lord help me. Did I multiply these two together and get the identity matrix. Yes, 1, 0, 0, 1. Okay, perfect. Now, in order to prove for sure that these are inverses of each other, I now have to multiply which way? B times A. I got to go backwards. I'm going to have to say B times A. So rewrite B. B is 1, negative 2. Going across 1, negative 2, 1 and negative 1, right? Times A, negative 1, 2, negative 1, 1. This is proving. Some of you are like, I can just look at it and tell. No, prove it. All right, first row, first column. We're finding that top left. So 1 times negative 1 is negative 1. Negative 2 times negative 1 is 2. What's negative 1 plus 2? 1. First row, second column. I'm finding top right. So 1 times 2 is 2. Negative 2 and 1 is minus 2. So 2 minus 2 is 0. Bottom left. Second row, first column. 1 times negative 1 is negative 1. Negative 1 and negative 1 is plus 1. What's negative 1 plus 1? 0. Second row, second column. 1 times 2 is 2. Negative 1 times positive 1 is negative 1, right? So 2 minus 1 is 1. What did you guys just prove right now? That these two matrices are what of each other? Inverses. The reason why is because when you multiplied them, A times B, you got the identity matrix. When you multiplied B times A, you got the identity matrix. In order to prove that two matrices are inverses of each other, you have to multiply them together, forwards and backwards, and you have to get the identity matrix. If you multiply them, and even one entry isn't in the right spot or the right number, then they're not inverses of each other. Does that make sense? Okay. All right, now we're going to talk about how to actually find the inverse. Now think about it. Algebraically, I have y equals blah, 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 blah. Algebraically, what did you guys do to find the inverses? What was the first thing you had to do? I said find the inverse. Before you start to solve it, you have to do something with x and y. What do you have to do? Oh, guys, come on. If I have y equals x plus 7, and I said find the inverse, what do you have to do with x and y? You got to switch them, right? You're going to have to do something similar to that when you're finding inverses here. This is how your setup is. All right, we're going to talk about major diagonals and minor diagonals later. But notice what I have in blue and pink, and then notice the quote-unquote formula to find inverses. What does it mean where it says major, that major diagonal where it says switch? What happened with the entries of A and D when you put it in the formula? They switch places. All right, the minor that I have in pink, it says negate. Look at the signs of B and C, and then look at the signs in the formula. What happens? They become negative. If something is originally negative, if you negate it, it becomes what? Positive. All right, so in order to find the inverse, you have to find this value here. And then we're going to plug it into this formula. After I do 2 of these, you guys will never have to look at this formula again, I promise. But what you're doing is you're going to switch the places of top left and bottom right, and then you change the signs of top right, bottom left. You switch the places of A and D, change the signs of B and C. And then you're going to find this value and multiply it in. So let me show you how I think the easiest way to do this. I think I changed the order of the notes, so just find example 2, wherever that is on your notes. If you need to kind of get in the habit, go ahead and say this is A, B, C, and D. At the beginning, that might help us out a little bit. But the first thing I personally do is I'm going to say, okay, I'm finding the inverse, so A negative 1. I'm going to get this already set up. What do I do with A and D? I switch their spots. So the negative 3 is going to go here, and 1's going to go down here. What do I do with B and C? Change the sign. So positive 4 becomes negative, and negative 1 becomes positive, correct? All right, I'm just getting my matrix set up. You do not have to do that. You can do this other step first. You can do A times D minus b times c if you'd rather. But you're just going to figure out what you're multiplying, what your denominator is going to be. We'll talk more about this tomorrow. But a times d, so 1 times negative 3 minus 4 times negative 1. Well, what is 1 times negative 3? Negative 3 minus, what is 4 times negative 1? Negative 4. So this becomes negative 3 plus 4, which gives me what? 1. All right. Where you guys will make mistakes is you forget to switch or something, or you mess up that sign in that little formula. So if you come out with, oh, it's negative 7. No, it's not. Make sure you plus the minus the negative becomes positive. So when I set this up, this fraction out here is 1 over 1. Well, what do you guys notice about 1 over 1? It's just 1. So if you were to distribute this throughout, the inverse of this matrix. Okay, so negative 3, 1. And then when I multiply here, I get negative 4, 1. So the inverse of A is right here. Now, if you guys look at that, do you kind of see some similarities? Do you see how 1, 4 is positive on top and negative 1, negative 3 in your original? And then in the bottom one, they switch. Instead of being in the rows, they're now in the columns. Do you guys see that? You see how 1 and 4 were together, left to right. 1 and 3 were together, left to right. And then when they switched as inverse, they went on top of each other. Now, I'm not, that is in no way how to figure out inverses or anything, but do you see that there's kind of a relationship there? All right, sometimes you guys can look at things and be like, oh yeah, that looks like they're inverses of each other. Sometimes you get something totally, completely different and they're actually inverses of each other. But how could I know for sure that I did all of my work right and that A and A to the negative 1 were inverses of each other? What could we do to prove that? You could multiply. You could multiply A times A negative 1 and then multiply A negative 1 times A, and you should get that identity matrix both times. So anytime you want to check these guys, you absolutely can. I'm not requiring you to, but you absolutely can. So let's do another one. All right, let's look at this one. Okay, I'm going to do it a little different this time. I'm going to find A times D minus B times C. I'm going to find my denominator of my fraction out in front first. So I'm going to say 3 times 2, right, A and D, minus negative 2 times negative 1.
I don't know if it matters, but which one's like B and C?
This, it does matter. This is A, B, C, D. So 3 times 2 is 6. Minus, what is negative 2 times negative 1? 2. So my answer here is 4, correct? Right, negative 2 times negative 1 makes it positive. So then it would be minus. So if you're going to get your inverse set up, I'm going to figure out my inverse. And I have 1 over. Well, this value was 4, so I put it right here. And then before I can distribute, I have to switch some stuff and negate some stuff. What switches? What switches? All right, what numbers? 2 and 3. So 2 is going to come up here. 3 is going to go down here. And then what happens with the negative 2 and the negative 1, the B and the C? They become positive. So this is going to be positive 2 and positive 1. Everybody with me? And then what do I do with 1/4? I'm going to distribute it. So 2, and we're not using decimals ever in here, guys. What is 1/4 times 2? That's just going to give me 1/2, right? What is 1/4 times 1? It's 1/4. What is 1/4 times 2? It's 1/2. And what is 1/4 times 3? It's 3 over 4. Now, do those two look even remotely like they would be inverses of each other? No. So don't just look at it and be like, oh, there has to be something wrong. I must have done something wrong. Just because you get something that looks completely different, it does not mean that you're wrong. If we check this, right, let's multiply A times A negative 1. Let's multiply. A is 3, 2, negative 1, 2, right? And then B, or not B, sorry, but your inverse is 1/2, 1/2, 1/4, and 3/4. So if you're going to go first row, first column. What is 3 times 1/2? 3 over 2, right? Then I have negative 1, right? Negative 1 times 1/2 is what? Negative 1/2, okay. What is 3/2 minus 1/2? 2 over 2, which is 1, correct? So now I'm going to find this piece here. I have negative, it's first row, second column. So 3 times what? 3 times 1/4, so 3/4. And then I have negative 1 times 3/4, so minus 3/4. What's 3/4 minus 3/4? 0, okay. So let's find this, bottom left. Second column, first row, so 2 times 1/2 is 1. Yeah, this should be negative 2. I thought. So negative 2 times 1/2 is negative 1. And then 2 times 1/2 is positive 1, so I get 0. And then this piece here, second row, second column. Excuse me, so, excuse me. Excuse me, negative 2 times 1/4 is negative 2/4, right? Yes? 2 times 3/4 is plus 6/4. You guys agree? Negative 2 plus 6 is 4 over 4, which is positive what? 1. What do you think is going to happen when I multiply the other way? A negative 1 times A. Do you think I'm going to get the same identity matrix? Yes. You can go ahead and try it if you want to. But what I want you guys to see is just because you find the inverse and it looks completely different than what you started off with, it doesn't mean you did something wrong. Your inverse is not always going to look like you have the same numbers, you just switched them all around. Yes, sir?
There can't be multiple inverses.
No. Good question. But you can check every single time. If you find an inverse and you want to verify that they are, multiply the original by the inverse and then the inverse by the original. And you should get the identity matrix every time. It has to work both ways. All right, let's do the last one. Let's find our value for A times, what is it? What do I multiply together? A times D, good, minus B times C. So 3 times 2 minus negative 6 times 1. What's 3 times 2? 6 minus a negative 6? Or no? This should be negative, shouldn't it? Yep. This should be negative 1 here, right? Yes, guys? Okay. So 3 times 2 is 6 minus, what's negative 6 times negative 1? Positive 6. So 6 minus 6 is 0. Okay. So I get 0 to go in my fraction. So let me get this set up. I have B to the negative 1, and then I have 1 over 0. So let's go ahead and get this set up in here. What switches spots? 2 and 3. So 2 goes here, 3 goes here. What happens to signs on negative 6 and negative 1? Positive 6, positive 1. Okay, now we distribute. Anybody? What's wrong here? It's undefined. As soon as you see that your denominator is going to become 0, what is that telling you about an inverse? It's impossible. There's no inverse. Just like you don't always have an inverse for every equation you have, you don't have an inverse for every matrix that you have. So you could get a denominator of 1, which is fine. You can get a denominator of any number, negative or positive, which is fine. You just distribute a fraction. Or if your denominator is 0 in this case, what that tells you is, like Jeremy just asked, could there be multiple inverses? No, there's not multiple inverses, but could there possibility be that there is no inverse? Yes. So once you get here, your answer is, oh, wait a second, there is no inverse. It's not undefined. You just say, oh, there's no inverse. Does that make sense? Do you guys understand why there's no inverse? Because this is undefined. This value here is undefined. You guys, we're good? Anybody need anything?